OMG. So basically, we just started. It's working. So let me show you what I'm watching. The German machine gun here. Video. Let's go here. Mega project. So let me go to the video. Switch it here. Camera on. Yeah. So we're gonna watch video. So highly tournament. Like gonna. What is that? Okay, maximum gun. So we got the light gun of Fennec. Obviously, I'm gonna use this maximum gun to my favor because it's very positive, but I have the gun inside the room. So it's really give or take, but I'm trying to not drift away from the theory. It's a machine gun. It's a light machine gun, so the gun can move. But the core principle really saying circular machine gun is having a strong foundation on the machine gun position. As soon as you hold it, can never lose. But like gunner framework, point man, wingman, like gunner, but they are literally someone that holds the space in time. In time, let's go in time. Basically, the time is access. This is the space to hold, but it's space time duality of the problem. Examples: look at the inside room and outside room. But inside the room, everything is literally the space and in time. So you can do it again in time for you to solve that problem. That's what we're gonna film. That's a like gonna film it. Playman, the person that does the common threats. Wingman, the person that does with ambiguous, kind of weird behavior of threats. And the like the person that holds the space so you can keep them going. We're gone. Yeah. Back to the drawing board. Back to the drawing board. So we got this here, and let me just try to take over my microphone. But this is gone here. Make it first of all, make it man gone. But one second, guys. Just watch me for a second. Just can't hear me. I'm hearing me. So this is gone on the board. It's like this. Can't sustain the fire. Like I don't know how to do this, but so you got the standard rifles. You're just gonna have soft loading. So it's soft loading. You're gonna have soft loading. Basically, you can just the jams. They have to be with soft, no. But the condition is a step. You can yes, it's better fun, but you really have to be there already. So you have to be loading. So those have stuff load. So you get the kind of reload all the time of the gun. Okay. Where's my light machine gun? I'm not doing the light machine gun. Might get this money. And because still get hundred hours. We feel about the future. If we can something good news to be kind of cool. Handheld, eating down check. And I check the bill. So you get up to 5 pounds. You have for sports and drones. So that's what you can do. When you are in this kind of position, what it's saying, when you're in this position, prone or squatting, it's a machine gun. So if you're reloading, if I'm like this, my back, and I'm literally facing a target, and looking on a barrel and shooting. This is what this is by people. I have to hold the bipod. I have to hold the bipod. Oh, I have to be prone. Let's be prone on the ground. So then I'll be this or prone, very like start like that's what we said. But it's a light gun. So basically, I'm going to have someone that's basically someone that's standing, or if not squatting, if not hunched, someone that's hunched, but it's gonna be able to go fast. So it's a light gun. The main one in theory works, but it's very bad. It's very bad. It sounds, but it's just really fun. It's fine. So let's be fine. So this is like a framework basically. So where was I? Like a framework. So let me go here and go to the video. So yeah, still TV. So what makes it different? So I think it's chamber. Chamber. You know it. Yeah. So let's see, single barrel rifle. So it has one hole. So I don't really know how this works, but I'm trying to define why not based on what jobs is it. But I'm saying I'll do my single, I'll do my single. So basically, I'm looking at the definition here. Mm. So, so basically, so I'm saying it has one barrel. You know, it has two barrels, right? So this is the end of the gun. This is a breech guide, this is the casing. This is the blueprint to get the drive motor, the gearbox, lubrication. Very important, you don't mess with it. It's gonna get hot. And you're gonna get the breech casing. So it's very difficult. The breech block carrier, the breech block, the breech. It locks out the gun, but it's spinning. So I'm busy. So, I sit in the kind of my one has better. So I'm going to choose model here. So I don't know how I'm going to do my model. I'm trying to put the bit in here. So you're going to have the body armor, the body armor, the skin armor, the attachment. Yes, that what I'm doing. So you're going to have the physical body, the metallic component, the metal itself. I'm not no opinion on the showcase. So you're gonna have the. So I realized that the bond control to make is have to be kind of structure. That's it's a human rights protocol from Sydney. And to remember Sarah, even the but the protocol has to show that can operate while you're fresh. What is about that? Because if you can't be steady like this, you have to be steady like this. But it's gonna be facing this way. It's gonna be standing. So I cannot eliminate standing with object. We should get a standing like that. But it's gonna work in kind of a way that works for anyone else. So you know, this is basically the blueprint here of the Gatling gun, of the like single, not the Gatling was rubbish. But it's a single barrel gun. It doesn't look like a single barrel gun, but it looks like it. It looks like you can see people. Oh, it's a barrel group. Oh my days. Ah, it's a barrel group. But it's not a single barrel, it's a barrel group. So the weapon is not a barrel group. What is the beauty of it? You can analyze it. So you get a rotation of pi and a half. Oh my days, this was so them do. So, pi half A, B, C. And you see, the beauty of this system is the analytical framework allows you so, I love this weapon. This weapon is perfect, it's beautiful. You see, that's the end of but it's side, I believe, the breed guide, the guide you talk about. I'm trying to have a sensor model of this. It's like an idiot. So it's angular. So basically, you gotta believe yourself. Your position, basically, how you do. But the goal has to be able to spare room. But the room is basically what the person does. So what am I saying? So basically, you got all this stuff. I don't really know what they are doing. But I'm trying to use this six main principles. Six main principles. This was one video. So six main principles. What do I mean by that? What do I mean by that? So, see the principle. So, I remember you're gonna have the steadiness. I'm gonna focus on three main things right now. So, you're gonna have the stability of the gun. Perfect. It has to be 95 at all times. It has to be I'll say 95 for prone. Prone has to be, so when you're standing, the ratio will be let's say 80%, not 80% to 100% stability. And if you go to 90% to 100% if you're crouching. And basically 85, you get to 80%, you get it 95, you get so 80% to stability. Basically, but the range has to be so it's a hit cam system. So the first thing is a hit cam system. So basically, if I'm holding a gun, I'm facing right. And I'm facing this direction, facing this camera here. I'm watching my so the image just the camera above me. What I'm looking at, and I'm going to just it's a hit cam system. So I'm doing more as a hit cam system. So it's a hit cam system. So I'm trying to just hit a target but that's in front of directly from me. Doesn't matter the range or not. It's usually the range that's called hit scan, but the range doesn't matter because it was reversion. So hit scan system. So basically, I'm trying to reduce the thermal. I'm trying to map the type pattern to the kind of rotation, revelation revelation, not rotation, which is like a rounds per minute, RPM. So a circle, basically the circle dictates the kind of space, But this one where pointing the gun, the position is there. So it's a precise system. It's a hit count precise system, but it's not working on angular momentum. But the goal is basically to work the relation. Let me think. The relation over a system of angular momentum. So you get hit count, but it's not hit count system. It's just like because it's not a projectile. The bullets for hit count isn't like a projectile, but it's a gun model. So it has to be a system of. So you got the light gun. So one more, what is a light gun? The light gunner. So this is a light gunner. It's a light machine gun, but it excels when you're squatting, when you're prone, or when you're lying down, or that. So it's usually for a 3-person. If you're going to circle the machine gun, you don't want to be in the machine gun zone. Say the zone, say this is a grid of spaces where you can be in anytime with a circle, but these spaces are literally targeted distance. So this is space. They're looking at. But the growth structure, this is telling but don't worry about this. I'm trying to invent it properly. You see, it's got a light gun, a machine gun, a light machine gun. So light machine gun framework is literally the video of the system series I'm working on. But it's a gun I'm trying to have built, for stability, But it work on kind of projectile nation. So you get these kind of weapons, they get projectile weapons. We have to travel a trajectory. So the trajectory is basically you having the gun should have a trajectory, travel a trajectory, travel a curve, But the curve is the path it follows. So this kind of straight line, fine, straight line. The thing that this thing works is that these are problems that we usually gun, we shoot a gun, but they called ballistics. We call ballistics. When you're studying, I have to remember when you're studying things that curve, you're doing ballistics, machine ballistics. Whether it's about projectile ballistics or not. But to hit the target, of course. So the projectile form is one example of a ballistic system. A ballistic system, we have to be part of that system. So it's called ballistic. So as we move to back to the board, you're going to go rocket science. Go rocket science. So basically, the rocket science is how rockets stop. You go ballistic. So if you go to you get the OBINexus, so which is a bomb thing, which is like the big bomb. But that bomb can blow people, OBINexus. which is looking the different bomb that consists of. But this is the system that's for heavy metal. So this is really for it takes some anybody people can have this light gun now. But if they're not really in a space, it's not really now. It's really not useful. But it's like when you can stand, when you're sitting on a plane and you're doing this, but you are holding the gun. So you're not. So I bend my knees here. I'm holding the gun. I bend my knees here, and I'm not. See, I'm not sitting. I'm half sitting. So it's a half sit position. It's like me. So I can sit on standing there, because the gun has to allow me to stand full option just by moving my own half space. But it's gonna be fully interesting to see how it will work. But professionally, I've got it all on them. So the gun is basically it's gonna have a half sit position. So you sit it down like sit down, you're gonna half sit, half down, half sit. But the gun is basically gonna do it. So this is like gonna make it. So next is the stability factor. So, it's not really a target per se here, but, I'm trying to find a standard screen. I'm going to define this properly. So, I'm still going to use against but the getting gun is not that. Really, God has spoken for limitation. So, you get pi with 2, you get pi. Now, pilot is half rotation, but it's really not just the circle. So now we're doing the circle 2, but this is not single barrel, this is like a barrel. So this is the barrel of the system. And you're going to have one barrel, one way to working with it. But it wasn't relation. So the bullet has to spin round the system, round the gun. Or is it go upside down? I don't understand. But I'm trying to think of it cinematically, dramatically. So if it goes, if it gets fed, this is sorry I'm thinking about. I'm thinking about this. Basically, you have to chamber and rechamber, and you have to get a lot of stuff up. So you get the kind of system here of the gum, but it has to be working kind of way that allows you to move, your peripherals. So the problem with the machine guns is they're heavy, and their peripherals, the peripherals are very small, very large, small, very large, but you cannot shoot them. So you have the heavy gun, and you cannot move your gun in time. You cannot move your gun in time. So move your gun in time. This problem is one on so first. So I want it to be light, very light, and you can almost snap. You can snap. You can use it so you can move your gun. So you can move your gun. Move gun. So it's basically a relational system of knowledge. So the heavier the gun, the more harder it is for you to move it, to shoot something, or move it to. You can use your sway system. It's not sway. So it's a problem for the gun itself. But that's the problem. It's not gonna be like that. So this is like I'm trying to formalize it, but I'm trying to have more ideas become my head first. So let me tell you. So you're gonna have to build like that, but so you're gonna have the semantic system. Well, I'm gonna do something you can go on anyone move again. You're gonna have two. You're gonna have two guns. So you're gonna have my model on the left, on the right. My model right would be to get pi over 2, pi over 2, pi over 2 and pi over 3. Let me do pi over 3. Let me do pi over 3, pi over 2, 3. So it's like a burst. So yes. So basically, this is called the noise start. So basically, the noise start in this machine will have pi over 3, pi over 2, but this is basically a function of time. So basically, you're gonna have a relation. So you're gonna have the mechanics go up and down based on the frequency or the magnitude. So, for example, the frequency would you take so if I honestly basically you go Roboban kind of Roboban the kind of rubber band gun here, but it's not rubber. You gotta have my gun here, my rubber gun. But rubber gun gonna hit the trigger, so you have to keep get it to start triggering. But problem with the pistol, basically, I'm trying to balance the kind of pistol in with this, but it's not to reserve distance and stuff. Basically, you're gonna have power two, power three, power two. Power three, but this is a resolution per minute, so you don't know what you get. So if you get power three at the start, it will stop. It goes really fire. But power two is when the gun starts to fire again in case you get jammed. So I'm trying to get the thing about jamming as well. So the jamming will be power three, power two, power three, and power two. Based on the kind of rotation of the system. But it's normally power three, power three, power three. And that's only factor. But if it comes consistent, it's power two. So you know it's going to have to jam. So you know it's going to slow down. So you know you're going to jam. It's your power two, a very distinct sound from power three. But it's rotation. So you get the function of sine. Let me try to use what about sine. So sine. We try sine pi over three. Sine pi over three would be sine pi over three cosine pi over three. Become secant law would be minus sine. So when I do the sine, I get minus sine pi over three. When I do pi over three, what do I get? I integrate I times by the minus one, I divide by the power one minus one plus something off. So I divide by the power. So basically I take the square root of sine, square root of sine is equal to minus sine plus one. That would be 2 divided by, let me get my calculator. I have my calculator here. My count here. So my calculator. So basically, when I have this sign, when I get divided by the power, times the power, I'm divided so I have to I want the power divided by the power. So let's go times the power. Also divided by the power. Also for the power. Divided by the power. Minus 1 to the power. That's integration. That's differentiation things. So basically, there's basically a table. It's a little table for these kind of systems. Because the system has to resolve 2, 3, 2, 3, or 2, 2, 2, 2, 2, 2. So I'm trying to have the right and round. So I'm trying to integrate sine pi over 3, cosine pi over 3. That will be sine. Basically, that will be sine times sine. This is minus sine. So that will be sine times. This will be pi over 3. Which is pi over 3. So 2. So you're gonna have divide and times. Times by the whole power. Divide by the power. Times over the whole power. Divide by the power. Divide by the power. Divide by the power. So times over by the power. Add up to the power. Power. So that would must solve. Times with one power, times with power, power. So times with one power will be I times power. So you get a forward revolution here that can be 2 or 3. You're not going to revolution of 2 or 3 because I'm going to know that. But you're going to have some so pi over 2. I don't know what this corresponds to. Yeah, it corresponds to 90 degrees. It's going to 45 Basically, it's Angular. So you're gonna have like Pyro. I'm thinking, guys, Pyro two is 90. Pyro two is 90. No, Pyro two is minus 90. Pyro three is minus 102. Pyro four is minus 270. And pi is 360. This is one rotation, one spin, one period of time. But we have this side. So sine is a significant if we expect to integrate pi over 3, pi over 3, I guess pi times pi is pi squared, or 2 pi, 2 pi. Let me see if I can figure out to do it. No, I can't do it. Come on, I can't do it. I don't know how I did it. But you should get to minus sign, so integrate. Let me just ask my computer to do it. Let me just ask you the question. Let me just ask the question. So let me just add ChatGPT's question. Integrate. This is my sensor theory. Could use here, but I was doing this, but you can sense kind of pressure. So this is the revolution once again. I'm using this is sensor theory. So this is integrate this is sensor theory. So this is dimensional sensor theory. So they work in dimensions, and dimensions have a meaning, density. They mean some kind of a system can be used kind of that energy. But therefore the power to integrate the power to force integrate sine pi over 3 uh, and plus cosine pi over 3. Let's see what's pi over 3, not pi over 2. Let's see what it says about this. Pi over 4, integrate pi over 3. It should fail. Let's see. You want to do sine, cosine. Oh, yeah, it's the square root of the 3 over 2. Oh, so the 2 has come down. So, it was 1.5. Square root of pi over 3 cosine pi over 3. So the sine will become square root of pi over 3. Multiply them will become, because they're trigonometric functions, cosine to 3 will be 1/2. So times 1/2 will be pi over 3 times 1/2 3 over 4. And you get a rotation of that. So you're gonna have, if you want to push into intuition or fold into dimension control framework. Yeah, so basically this dimension control framework for the sensor tree. So so you can know where the sensors are being violated. So equation of x 3 over 4 ratio of x equals square root of 3 over 4. X will see what is constant, but the square root comes from where? C. But the constant from the C. Yeah. So the sign of trigonometric function. This is the rotations of the one. This is basically what the gun is spinning. Revolution. But the revolution is basically rounds per minute. Revolutions per minute. I don't know rounds per minute. RPM. So that's the system. Apply. So this is the dimensional activation. This is very important here. So we use it to do it. The sensor of student confidence. The sensor 3. Reject notation. A sensor. I applied this is what I'm saying. I don't even know I'm doing. But this look at the kind of sensor G sense is a dimension, basically the working dimension, the working kind of the space to operate the environment. So this takes into the environment too, just like just like so as the sensor domain sensor agent, potential energy, quality flow, zero cost function, and this Laplace equation. Well, this was really something for something else, but this is what I made from sensor control. But because this is a control and collapse, was collapse control, same thing. So it's not the same thing; it's different thing. Because if it can grow, it can calm down. So the what is bracket E? The element n is less than 4. Theorem of integration control. Yes, usually I'm done with this kind of model. So, the goals that have to go, originally, that's something I was reading before I come here. Don't worry about it, guys. Uh, Understood. So, the goals to have the system, what kind of resolution? But you see how the integration was? It was a revolution. So that's what kind of spinning our system. But Michael is going to spin too mechanically, but it's going to be because the more cogs you have, the more final control you have, you have to have more breathing for the system. So it's not around to breathe. So you're gonna have a 3 to 1 mapping of the system. Maximum this you can come to three, because we're firing, but it's gonna be a fire. It's gonna be a machine that you can hold whilst like standing. So let's just watch the video. Finish the video here. Oh, let's finish the video here. Let's finish the video here. Um, come and find a gun. So I'm saying. Water kill is so effective, guys. It's so effective. So if you have to use water kill to do it, yes. Look at this guy squatting. That shoot to squat and move to the five against system. See that releasing it. Basically, it's a tripod, It can sit down. He's risk sitting down. So what's the problem? He said, no, I can sit down and make it sit down. So let's the no person to I'm sorry guys, you sit it down. But you know, this machine gun too. So I'm trying to tell you guys really, I'm trying to tell you guys to check this out. Now, basically, got the three people doing it for me, myself, and I. But if it hurts me, it hurts me, not you. So so basically, you're gonna have a circle. You know, you're gonna have three. So this is basically the line of sight person here. Here, machine gun facing this way. Here is one person has another person in. But most than half, this machine gunner cleared the way. So this machine gun was the center of the whole tactic dimensions and dimensional systems. Tactic and basically he's the main guy. If you want me completely, basically, I love this guy. So it was moving forward, basically. Yeah, so that's what I'm saying. You keep on moving, guys. My guys. Okay, thank you guys for watching the video.